Hello. Hello and welcome. Good evening to the third event of our lecture series Jour, Fixe, Sandgespräche from the Architecture Apartment here at State Academy of Fine Arts Stuttgart. My name is Constanze Becker.
And I am Carla Nordmann. We both study architecture here in the master program at the ABK Stuttgart. And this will be the closing event of the Jour Fixe this semester. First, we want to thank Beton and FSB that supported us during these events.
These lecture series are called Sandgespräche, Sand Talks, because we wanted to talk about the resource sand as a metaphor and raise questions in regards to climate change. In recent years, the demand for sand has increased dramatically, and after drinking water, it is one of the most used resources on Earth. Sand is mainly used by the building industry, but actually it surrounds us in our daily life constantly. Glass, ceramics, plastics, and even cosmetic products contain of sand.
So the questions we focus on during these events are: how can we as architects or architecture students design a sustainable transition within our society? Are there alternative ways of construction? And what role do we want to take on as architects?
Today we have Amin Taha as our guest from Groupwork London. We are very excited and happy to have you and looking forward to this event. Welcome, Amin.
We just have to make sure that Amin is here. I don't know. Ah, yeah, there he is. Hi. Hi, Amin. We are going to introduce you. Please do correct us if we are wrong.
Okay.
So you were born in East Berlin and moved soon to the UK, graduated there from the University of Edinburgh in architecture. And in 2003, you set up your own practice after working for various architectural practices such as Zaha Hadid Architects. Groupwork and Amin Taha has international recognition for its built projects, including multiple awards, and all of your projects are published globally.
I'm not going to argue with that. Sounds nice, yeah.
A well-known project is 15 Clerkenwell Close, a mixed-use building that makes innovative use of load-bearing stone. And this is an example of a potential alternative material to the current most used material, sand, that we are interested in. Since you are challenging conventional ways of doing architecture, we see it as a great chance to have an open discussion with you as a practicing architect and to talk about strategic ways towards a sustainable architecture.
Yes, I will just give a little overview in terms of the timetable tonight. The evening is split in two parts, a lecture or input from you and a conversation afterwards. The lecture is titled Etymology of Architecture, and we invite everybody watching live to put the questions you have or you might have into the live chat, and we will integrate them into our conversation. So
okay.
I think we are ready, and if you are as well, you could start with the presentation and we will just, yeah, it works, perfect.
There we go. You can see that, yeah?
Yes. Okay.
All right, I'll try and, I'm aware we've split into two. The lecture itself is split into two. The first half describes why we do what we do and really how all architects should start their design. So it's titled Etymology of Architecture, and I'm starting it with Giorgio Vasari, who's a 16th century painter and architect. He publishes the most excellent artists, sculptors, and architects in the 16th century, and he includes himself amongst these. It's the first, effectively, history of architecture book and it lasts for about 200 years. Now, the key difference between that particular book and pretty much everything that's followed is that it's before the discipline, the strict academic discipline of history of art and architecture. So it's very much anecdotal. He's listing individual artists, sculptors, architects, and so on, listing them and telling you about their life stories more than anything else. So he begins by telling you that they might have been the son or daughter of such and such. They were apprenticed to another sculptor or architect. They spent their 10,000 hours of apprenticeship there, and during that period they might have learnt to read a particular text, so a humanist text, for instance, and then also innovated in their craft as a result, not just as a result of reading a particular text, but also in working in that particular material. So the mixture of mixing their pigment in a particular way, sculpting in a particular way, and in that innovation became masters in their own right. Now, the key there is that style, if you like, is termed manner, the manner of an individual. So style is not a homogeneous title to a particular period or a group of people. It is the manner in which that it's idiosyncratic to an individual. And it becomes idiosyncratic because that particular individual has been apprenticed, he's learnt his craft, and differently, and then influenced it with whatever they're reading or their other life influences. 200 years later, it's the period of the Enlightenment, so everything has to become a bit more rigorous, scientific, as it were. And the first proto-archaeologist come historian is Johann Winkelmann, who tours the ancient world, and unlike previous grand tours, he's actually mapping out, he's drawing and mapping out archaeological finds, projecting them, and then also dividing them across a period, and establishing a book that is effectively the history of ancient architecture. So that spans the Mediterranean to Greece as well as Rome. It becomes a bestseller, and then he follows it up with a second publication, which is his opinions on Greek architecture specifically. And you have to remember it's the Enlightenment period, so he's very much interested in conflating the politics of the Enlightenment. So man is in control of his own destiny. We must let loose the shackles of autocracy, of a monarchy that might rule over us. That's apparently been given their power by God. And for him, therefore, the Greek is better than the Roman, which is autocratic. It's pseudo-republic. It's certainly better than the Egyptian, which is highly autocratic. And so he's conflating there a style. So first of all, in his first book, he's essentially saying this is a period. That period and that civilization, that culture produced these styles. And then later on in his second opinions, he's then conflating it with politics. So we have to remember he's not an architect, he's not a sculptor, he's effectively the proto-academic, the Enlightenment period. And from there, we have the beginning of the neoclassical age. So from there across Europe, anybody who's part of the Enlightenment adopts the Greek, because Winkelmann's manifesto is very clear. If we are to be as independent as it were, and great as the ancients, we have to literally copy the ancients. And one day the ancients will people in the future will look upon us and think we're as great as ancient Greece and Rome, but specifically Greece. What he doesn't know, of course, because he's digging up bleached marble, what he doesn't know is that they are obviously polychrome. So the legacy of him suggesting that the whiteness of Greek stones is better than Roman polychrome or Egyptian polychrome or other Mediterranean cultures as polychrome is representative of a pure democratic period, is actually flawed. Worse still, of course, because he's not an architect, he doesn't understand that there's an architectonic origin to what he's looking at. So these patterns and motifs, these decorations, this ornamentation is not just an abstraction, it's actually an abstraction of an original timber architectonic making that put these buildings up. So unlike Vasari, who's very much the verb before the noun, what's happened by Winkelmann is the noun has occurred, and we are now copying a style, a two-dimensional image, if you like. The inevitable result of that is this sort of product that you see at the bottom, where people can, you know, the current fashion probably in Germany too, but certainly in the UK, is to what we call brick washing. So you draw something and you apply a brick render to it, and suddenly it looks contextual and pleasing to the eye. And inevitably, if that's the sort of Winkelmann philosophy, which is effectively what's determined architecture for the last 300 years, why not let a contractor and a manufacturer innovate their products that you can just simply apply a brick skin, as it were, wallpaper. And the big question, therefore, and this returns to your fundamental question, your lecture series, is why not? Why not let that happen? Well, if you look at the diagram on the right, that tells you how typically we build today. So a superstructure of concrete or steel that then would be thermally enclosed, waterproofed, fire rated if it's steel, and then whatever cladding, brick or stone or whatever it is, applied to the outside of that. Well, the reality is brick can hold itself up, can't it? If it's not going to hold up the building anymore, it can certainly hold itself up as a skin. It's called a self-supporting skin. And you can get rid of most of those other materials. So the question is more of an ethical one. So if you understand, as Vasari's architects did, the nature of those materials you're working with, as you put pen to paper, you already begin to think it can be stone, it can be steel, it can be concrete, it can be timber or brick. How do I bring these together? Do I need any more than that? And why should I use one over another? Once you understand that, you automatically limit the quantity of materials you use. So the key question is not necessarily the material, it's just the material itself. Is it a sustainable material? But also the quantity of material. Is it necessary to use the quantity of material? Surely one material can do the function of 2 or 3 others. So inevitably, some time after Winkelmann, people begin to question why for the last few generations as architects are we just copying, reproducing this neoclassical style? Where on earth does it come from? Why? What does it mean? And there's a number of German academics, including Semper, of course, who are asking those questions. And then while Semper and Marx were expelled from Germany because of their sort of revolutionary ideals, they were in London, and Marx is in the British Library preparing Das Kapital, and Semper is in the British Museum looking at the new archaeological finds that have come in from Mesopotamia, what's now Iraq. The insight he has while looking at this stool is that all architecture, all applied arts and architecture are what he calls, have their origins, their etymological origins in joining, binding to complete their architecture. So what he means by that is literally how you join 2 pieces of timber. You might bind them with some rope, and then you complete it. And what he means by completing is that the joining and the binding become ritualized. So for a throne, eventually they become ritualized in their particular knotting, and that knotting becomes abstracted in carving, perhaps into the timber instead of literal pieces of rope. And eventually that pattern becomes abstracted in terms of carving in stone or terracotta and other polychrome decoration ornamentation. But it's emblematic of a particular culture, and therefore reinforces that culture. And his question is his and other people who questioned at the same time. So at the bottom, you've obviously got Ruskin, and to the left of him, you've got Owen Jones, At the top left is a French chap called Jules Goury, who worked with Semper. He was a sort of research assistant who worked with Semper and Owen Jones. And he was very much interested in not only just polychrome, i.e. things weren't all white, they were actually colored, but also what eventually Semper and other German academics called Kunstform and Kernform. So the separation of structure and decoration, ornamentation is, as one is the architectonic elements that hold the building together. The other one might be the facade that might be representative of those original architectonic elements, but is now motif and decoration. They obviously influenced Otto Wagner and the New Secessionists. You know, the Postbank. I'll skip through these because otherwise we'll take far too long before we find our own buildings. And below, Henri van der Veld, who effectively was part of the Jugendstil Art Nouveau in Belgium, but then went to, you'll know this, you'll know more about this than I would if you've done your history of architecture, effectively became the first head of the Bauhaus. Now, after the First World War, he was actually banned from being head of the Bauhaus because he was Belgium, but he recommended Gropius, who then took it over. So that was the joining, at that point, the art school in Weimar, was technical college, wanted to join, and it was his direction that they should join and follow these new principles, the sort of William Morris and Werkbund principles, slightly socialist ideals of a whole art being also socially driven. That obviously then matured with in Dessau, and then eventually fell in Berlin. Now, today, the sort of the person who's interested in pulling apart effectively what I might have skipped a bit too fast across there, so you can ask me questions after that. But today, who's the person who's asking the same sort of questions that Semper might have asked 100 odd years ago is somebody called Edward R. Ford. And what he's done, he's essentially, in the same way that Semper looked to the previous couple of generations, Ford is looking back a couple of generations saying what's happened to our details, specifically in modern architecture. And he's pulling them apart and saying there are 5 types of details in his opinion. There's the non-detail, which is trying to hermetically seal, trying to make your building look like it has no joints at all, as if it's literally just been born as such, as a solid object, a hermetically sealed object. There's the detail as motif, so that's much earlier on in modernism. You might even go back to sort of proto-modern Louis Sullivan, where they're struggling with the idea, they're coming out of the Beaux-Arts period. How do you represent this new period? In the same way that Viollet-le-Duc and Semper are asking, how do you represent a new period with a new architecture? And Sullivan's doing it with motifs, as it were. And there's the representation of structure. So that's Mies having to, if you like, and Philip Johnson, etc., his followers, having to strap structure, what appears as structure, to the outside of structure to make it look like that is actually what's holding up the building. And there's the detail as joint. So the details that Edward Ford is interested in is what he calls well, effectively he's saying they're the legitimate details, the last 2 there, the detail is joint and the autonomous detail. Everything else, the other 3, for him are effectively faking it. You're adding more material than you need. So for Ford, the detail as joint is where you're articulating how materials come together, and the autonomous detail where you can allow a door handle or some other detail to speak for itself, and it can undermine or subvert the overall detail, but it's part of the overall narrative. For Ford, those are the 2 details that all architects should be working with. Okay, so I think I will get into our own schemes now. Barrett's Grove is our first all brick building. So as I was saying earlier on, there's a fashion, been a fashion in London for quite a while now. Brick everything, yeah. It's the first one that we said we'll actually do because we're allowed to do it with the contractor. Excuse me. in a part of London that within short space of time became highly dense. Most of that construction is what we call pattern books. So there were contractors who are also developers. They followed these pattern languages. But if you look carefully, those brick walls are actually the superstructure that holds the whole building up. They're just being composed in a way to be pleasing to the eye. So our challenge is, can we build in this inexpensive architectonic way that still has the same sort of charm, that also holds a certain sort of charm for the next few generations. Our solution is today's requirements, thermal requirements, waterproofing requirements are obviously very different. You can't build in solid brick walls anymore for thermal and waterproofing reasons. But what you can do is the superstructure fully in cross-laminated timber and a self-supporting brick skin. So it becomes the brick that's required by our conservation area, but it's self-supporting. So the advantages of that in detail are that the cross-laminated timber is the internal finish. So there's no plasterboard, no other finishes internally. So you've removed a great deal of material, labor, and time on site by allowing the brick to support itself, because bricks are made the same way as they have been for the last 200 years, perfectly capable of supporting themselves for 5-6 stories. All you have to do is pin them back to the superstructure to stop them wobbling and falling into the street. So you're not supporting them back to the superstructure, you're just holding them back. Yeah? And the key thing about that is the superstructure does not hold the brick. So currently, pretty much every building that's made in brick, every floor picks up the brick, which means the superstructure has to take the load and then transfer it back to the foundation. So ultimately, your superstructure is twice the size it needs to be. Completely perverse when the brick can hold itself up. So you don't do that, you lighten the superstructure, and the other advantage is the two can move separately, expand and contract separately firmly. There's all sorts of other advantages in terms of you don't need expansion joints, you don't need weep holes, etc. It is a self-supporting skin. It does not need to be a self-supporting facade in terms of, sorry, a load-bearing facade. And as a skin is ultimately just a rain screen, a ventilated rain screen. So why bother making it absolutely solid? You may as well just leave holes in there to ventilate. Now, this is ultimately the interior. It's all across laminated timber, which today you might find acceptable. But when we first proposed this in 2014 to our client, their agents said, well, no one's going to buy this stuff, but they did. Now, the important lesson here for architects is to understand what your standard commercial clients want. The diagram on the left is standard funding model for all private sector clients. What you call profit is actually what the bank calls risk. So if the market collapsed by 25%, the bank is not left with negative equity on a site. But the client ultimately develops the scheme and takes it as profit. If you, as an architect, lower the construction costs, because ultimately what we did was we reduced the quantity of material on that scheme and saved the client about 25% of their construction costs. That actually meant the client ended up making 10% extra profit on their sales. Now, what that means is that really, as an architect in the private sector, all you're doing inevitably is increasing land value. You're not actually making housing cheaper because it's the private sector. However, if it was the public sector, if you keep innovating, then obviously the borrowing by the public sector is less because you've made the building cheaper, and therefore the rents can be less. So it's highly advantageous for the public sector, no good for the private sector. So if I've got my words muddled there, good for the public sector, no good for the private sector, apart from lowering the quantity of materials you're using, and therefore obviously being more sustainable. Now, what we found was that we lowered it by about 25% construction cost. It saved us quite a lot on our overall carbon footprint. And had we not been asked by the client to also build a basement to get it, expand a flat into that so it becomes a duplex, the thing would have been carbon negative. But building a basement, we had to build out of concrete, so it became slightly carbon positive. So the story of that project is it's how do you build mass housing fairly inexpensively, sustainably, the story on this one. By contrast, it's north of Hyde Park. It's got sun on it all year round. It's one of the last sites that has an opportunity for a mansion block. While we're undertaking these standard environmental concerns, our planning concerns, how does it fit on site, where are the bedrooms located, do you get cross ventilation, all the rest of it. While we're undertaking that, we also undertake on every project what we call background research, so social history, contemporary social history, as well as anything else we can find. Our immediate adjacent building is this one on just on the corner of our site by Muse Davis, who built the Ritz Hotel, the RIC Club, etc. Very much the Norman Fosters of their day. Lots and lots of projects in the Edwardian period and Victorian period. And this building was actually for, top left, the Prince of Wales, for his lover, who's to the right of him, Lily Langtry, who's an actress. And inside you can still see the proscenium arch and the sort of royal box at the back of it's now a hotel, at the back of the hotel, now a bar. And while we were undertaking all this planning, it occurred to us, we just had a thought experiment, the amount of louvers and solar control, privacy screens, and ultimately some winter gardens, which are also solar buffers, used as acoustic buffers. The amount of material and articulation in the architecture we're undertaking was already beginning to make the facade heavy without actually designing it. And one of us was just sort of free to do their thought experiment, said, well, supposing Muse Davis had finished the urban block, imagine if their facade was actually made out of 3 millimeters of perforated sheet that allowed us to have a very inexpensive and reduced material, real thermal facade. And then this thing is in front that does all the solar control where it needs to, and then opens up, so it's set in front of the winter gardens, as it were, and then opens up when you want your expansive views and you've got no issues with privacy. So at the moment we're it's on a very busy road on people from bus with, going to and from the park are looking straight into your windows, and buses are going past. So it had to have a number of these controls. That last project, so the story about that last project, apart from our general background approach of how you build, what you make things out of, leaving the decisions of those materials slightly late on in the project, because it might be, as you're doing that research, social research, historical research, that it gives you a reason to use a particular material and do away with some others. We came across this, well, we were invited on this competition on this site in Islington, which is a site that had lost the building on the right-hand side. It's otherwise a fairly intact terrace. There's nothing on that site for the last 60, 70 years. Our client bought it, held a small competition, and we knew we were up against 5 other architects, all of us going to be challenging this sort of idea of building in a historical context. And also we're directly opposite the town hall. The town hall was very keen on, literally rebuilding what was there on the site, but nobody's going to do that for all sorts of reasons. And some of those I've already mentioned. You can't build in solid brick anymore. If you want to build exactly the same, the quantity of space is reduced. It's not a large site, so suddenly you end up with a compromised program internally. And we said, well, look, we've just challenged the idea of building on the previous Bayswater site with a fake memory, an imagined memory, an imagined past. Here there was a past, and in the same way that on the previous site, when we went out to consultation and talked to councillors, they were very enthusiastic about seeing something that looked, in their opinion, old architecture. Exactly the same on this site, and no doubt we all come across this question. And for us, the question was, why really do we like that? Why do we feel comfortable as a social group? Why do we feel comfortable with the past? Well, for all sorts of reasons, we've got used to it. But more often than not, we imagine that the past is better. It's less challenging. It's stripped of it's got clearer ideals, if you like, and stripped of the uncomfortable realities. And for us, I mean, interestingly, I think in German, the word for monument is Denkmal, isn't it? But here it's just simply monument or statue or sculpture. While Denkmal is a bit more direct, isn't it? So here we forget that monuments are really there as emblematic of an ideal, and we're all aware, especially today, that those ideals are often very flawed right from the outset. So the idea of this project was, let's choose a material which speaks of flawed ideals. Yeah, it's a monument. We're recreating the past, but it's clearly the whole concept of recreating the past is flawed. So let's choose a material that does that. So this is a terracotta mix that was in situ. And if you can see in that section, essentially it's a hollow cast. So just like casting a bronze monument, it's hollow. And then a new inhabitation in there is entirely timber. It's all CLT. So, you know, on balance, it ended up being neutral because we're spending money on, or spending carbon and money on the skin, but internally it's all negative, you know, because it's all timber, apart from the fireplaces. I had to test this beforehand because no one had exactly done it like this before. So it's all in situ. It's not precast panels that are stuck on. The purpose of it being in situ is that the facade is actually holding up the building. So in that detail, you can see there, it's a twin facade with insulation in between. The two are tied together, and the CLT then is slotted into those brackets that are cast into the inside face. That's it, finished. What we actually did was we surveyed the building on the opposite side of the other end of the terrace. We took that survey, flipped it, you know, mirrored it by 180 degrees, as it were, and then sent that, translated that as a three-dimensional model to the company that did the routing out of the formwork. And we said, look, first of all, the material itself has flaws, but the process of us taking that model and sending it to the routing company inevitably will have flaws. We don't want them to correct it. And similarly with the contractor, we didn't want him to correct any flaws in the grout loss, because this sort of material doesn't want to be perfect. And then internally, similarly, we actually put wallpaper and with a release agent on it, so you get the print of the wallpaper. And as you can see there, everything else is just timber, apart from the fireplaces. We were asked to do another competition we won, but in Sofia, in Bulgaria, which is linking a green park, landscaping, transport interchange. We all know the common languages of infrastructure, especially tube stations, metro stations, and airports, and whatever railway stations. They come with an automatic language. And again, here, the question is, we don't want to immediately leap to any particular material decisions. Let's work with the engineers and find out how these things are normally made and see whether we can create any efficiencies. So it's that Vasari lesson, you know, understand from first principles how things are made, why they're made, and whether you actually need, whether you can allow those materials, the fundamental materials, the irreducible materials, you can allow them to perform several functions. The standard way of building a tube is either a metro is either tunneling or cut and fill. So this is a cut and fill process. Cut and fill is normally piling and then excavating. And as you're excavating, you put temporary props in position, and you keep excavating to stop the piles and the walls collapsing in. Now, that temporary propping structure has got a lot of wastage in it, but ultimately is around about a third of the budget of building these metro stations. It occurred to us with our engineer that supposing we don't dig out between, we just dig out a little bit to create a shallow curve. That is the dimension of any permanent bracing slab come beam between those two lines of piles, as it were. And then we leave holes in there and drop diggers and excavate the earth from underneath. And effectively, your temporary formwork is actually your permanent formwork, is your permanent structure. Once we realized that's possible, It reduces obviously the construction cost and the material quantities by a third. But actually, why does it not dictate the language of the architecture? So it helps form the architecture, and because it's linked to some landscaping exercise, why don't we allow it to essentially burst out the ground? It creates, basically informed us. So that story I was telling you earlier, while you do all this research, you allow these ideas to orbit your mind before they settle. And it occurred to us, actually, this is a narrative about a journey into the underworld. We can allow the language of this subterranean area to burst out and do it in reverse. It's a journey into the underworld. So it became a journey through the landscaping to the tube and back out again. I'll flick through these fairly quickly. Back to Hyde Park. I'm telling you this one because it explains Clerkenwell Close. Back to Hyde Park, classic architectural project. Family wanted to renovate this house they bought, expand it for their larger family, modern way of living. We put a new staircase in the center of the house, had to bring light in, so we left it as a helical stair with a skylight above, wrapping itself around this void and internally. Most of the house is just timber, but the staircase is what's called so I'm sure you have them in Stuttgart, especially in any older buildings. You're wandering around. Sometimes you look at the stone staircases there and you wonder, wow, that cantilever looks incredibly thin for a piece of stone. Well, actually what that stone is doing is not purely cantilevering out the wall. It's resting on the tread below and then transferring to load to the next tread, to the next tread, next tread. And that allows the stone to be thinner. It doesn't need to do all the weight, holding in the weight itself. And that's something that was only rediscovered in this country 20 odd years ago, I suppose mid-late 80s. But we suggested that instead of conventional method at the moment is to either concrete and steel and then clad it in stone or something, or in wood, why don't we just use the stone itself to do the structural job as it has been for the last few hundred years, dare I say millennia. That's it looking down there. And that was our first effectively lesson in stone construction. The other lesson we learned is wastage. So if you build a spiral staircase, the way it's cut, you'll inevitably end up losing about 50% of the stone. So we asked whether, if we give them a drawing that tells them how to cut a curve, can you just flip the stone and hand it and reuse it? And this is the experiment. We basically gave them a diagram. Their machines in the yard were able to change the drilling according to that CAD file, and then we had zero wastage as a result unless something broke. That's it being put up on site, temporary props. And while we're in the yard, we spotted some nice big stones, and of course we're wandering around London, looking at all these stone buildings that are going up, thinking, well, why on earth are people cladding as opposed to using these giant blocks of stone that seem to be able to hold up anything? So this is Clerkenwell Close. We're almost done. Clerkenwell Close. If you look carefully, this is conservation area number 1 in Islington. It's first listed conservation area. And the conservation officer at that time, this is sort of late 60s, early 70s, decided this area is predominantly brick. So he set the rule, that was it. And he's not an academic. He's not a proper architectural historian. He didn't really do much research. He just wandered around the area, decided that what what he saw around him must have been there always. It should be therefore always like this. And what you're actually looking at is all 1960s, 1970s, 1980s brick. Pretend old buildings, some good attempts at looking old, some not so good. So really he set a status quo which said, ape a reality that never existed. And I don't care what quality of study, academic research you do in terms of trying to make it look as original as possible. As long as it's brick, it is there for the conservation area. Well, we had the opportunity of putting something here, and that was not our attitude. We thought we'd challenge that. Obviously, that's another story, but Our site here is just outside the city walls of London. Nothing existed on the site until the Norman invasion. The Normans, some of you will know, are Vikings who settled in northern France. So you know, the Channel and North Sea, both sides of the UK and Europe essentially were constantly populated and repopulated by Danes, Vikings, and then the northern France eventually made a treaty with the King of France, and they became Normans and barons and given the area of Normandy, and eventually re-invaded England and got rid of the entire Anglo-Saxon aristocracy. And in doing so, created a new social structure, completely new social structure in England. And one of the reasons for their successes is that apart from being good warriors, they kept their land by building good fortifications. And what they'd realized is that innovated, if you like, was if you pull limestone out of a quarry while it's still wet, so it's under the water table, it's actually very soft to carve for the first 6 months. You carve it, you lock those stones in, and over the 6 months, a year, it calcifies and becomes incredibly strong. Of course, now we're using, for a long time, we've been using limestone and concrete for cement for the same purposes. So their fortifications, castles are all locked in limestone. Eventually, their buildings of state, religious buildings became similarly so. And this is an abbey built by them, by the first companion barons of William the Conqueror, by his family, who then went and expanded a series of abbeys in this area. And that's the location of our site. So on the top left is the Duke of Norfolk, who after 500 years of this abbey flourishing with Henry VIII, dissolved the Catholic Church and took hold of the abbeys. Duke of Norfolk turned it into his palace. It would have carried on existing as the palace, or at least the history of the abbey would have carried on existing if it hadn't been for his son, who fell out with Elizabeth I, was beheaded, and the abbey was carved up into parts and sold off to, or given to nobles who built their own smaller palaces. So slowly it was degrading. Eventually, William the Conqueror dissolved the monarchy. He destroyed these nobles' houses and built himself his own home, which expanded to become his sort of state, building of state. Because if you know, it was a nascent democracy. He didn't trust. He basically became dictator for life. And then after his death, they destroyed his house and his buildings of state, gave it back to the nobles, who built houses, mostly houses for rent, and that lasted until the Industrial Revolution. And you see William Morris there, who bought a property next to our site, and that's the one in the center there, and he called it the 20th Century Press. It was a Fabian society, what we call the Fabian Society here, which effectively became socialist and then proto-communist, really. And Marx, when he arrived in London, actually wrote for William Morris's press there. Lenin actually used the printing press for his Russian language paper. And to this day, when the Labour Party, our Socialist Party, starts their march every year, they start from this location. Today, it's called the Marx Memorial Library. So this whole area, because it was always outside the city walls, was always a bit radical, if you like. They were allowed to slightly easier, more radical rules than being within the city walls, all the way until the post-war period, where somebody decided this was a conservation area, and no matter what it is, please cease your intellect and just reproduce pseudo pasts, as it were, no matter how poorly studied they are. So we gave this history to our planning officer. We also said we've been slightly literal, and we've taken what would have been on our site, the servants' quarters, the timber servants' quarters, not the stone ones, and we've given it to a piece of software called what's effectively, if those of you are interested, parametric self-learning software, where we said, here are the rules. If it's a steel frame with a curtain wall, there's so much metal involved. Yeah. Can you reduce the quantity of metal that you combine? And how do you do that? And effectively what it did was create an exoskeleton and reduce the quantity of metal in doing so. but the exoskeleton was sized to a typical glazing panel. So it's a double glazed unit that then fits directly behind this exoskeleton. And if you look carefully, every time you add a diagonal to stop the building twisting, it actually reduces the amount of metal still. So there are nodal points. And you eventually strike a balance between adding more diagonals and then reducing the quantity of metal in the adjacent horizontal and verticals. All went lovely and swimmingly, apart from the new conservation officer who picked up the old conservation guidelines. And he was new to the borough. He literally said, the guidelines say it must look old or must be made of a material that used to be old. Please make it out of stone. We've got no problem with stone. So we reverted to the idea that the Normans introduced stone into this area. It turned out there were lots of quarries in this area. So why don't we go and visit some quarries and find out how to build in stone today, not necessarily with that previous slide I showed you, which is pretty much like that first slide with the brick I showed you. What we find is a stone is cut fairly inexpensively and quickly today compared to the hand tooling of the past. There's still some hand tooling occasionally left over if the stones come out uneven. And it gives you 3 types of very basic finish. Saw cutting, the sedimentary layer, that's the sedimentary stone, and some drill splitting with occasional fossils and crystals within it. And we said, okay, fine, let's see whether we can literally assemble no differently to the Normans, possibly even, dare I say, megalithic, where it's one stone on top of the other, and then bolt that back to the slab, as it were. So the thermal envelope is just a clean sealed line with a gap then to the exoskeleton. A fairly straightforward, simple detail. And then, you know, it's on temporary props, goes up fairly fast. Now, well, I think the only error we made in some respects is because we were trying to make those slabs out of timber. And we originally had this design on 2012, and we were trying to make it out of timber joists, and we eventually just couldn't make it work. The whole scheme went on the shelf for a while, and then it went out to tender, was ready to go on site. In the meantime, we built the CLT structures, so it was too late for us to revert to CLT. I think, well, we learned our lesson because the next projects then went to integrate CLT. So there you can see the exoskeleton. Exoskeleton means it's what's called loose fit, no internal columns. Loose fit is something that is a term that sort of, if you like, was defined in the 1970s. And the idea is that the building is flexible. So over the next generations, if somebody decides to subdivide it, there are no internal columns or walls that are restricting your flexibility. You can remove all that furniture that's highlighted. So all your partitions and walls are actually just pieces of furniture with integrated doors, 4 high doors. Remove it all, subdivide into smaller flats, a hotel, office space, without having to demolish any the whole building or considerable parts. That's it in its context with the various types of finish. These are the sort of autonomous details that Edward Ford referred to, which are play on the narrative that aren't necessarily related to architectonic elements, but they remind us of the history that's beneath our feet, as it were. Interiors of the office. You guys, some of you have been here, so you've seen all this. But I'm going to go through it quickly, and then ultimately what we call a blue and green roof on top, which is there for biodiversity, and obviously you don't take the water and put it into the sewage system. Lastly, that led to the research project, which we tackled, which is the idea that supposing you build, if you're building in 5 stories in stone, we've already got another building on site now that's 10 stories in stone where the floor plates are CLT. Can you build in 30 stories? And the answer is yes, you can. And you can see there on the far left, if all the floor plates, the core, and the exoskeleton are all in stone, it's less than half of the carbon footprint of the far right, which is the concrete one, and obviously a fraction of the steel frame building. If you combine, so the next one, scenario 2, if you combine stone and timber, then it's carbon negative because of the amount of timber you're using. so negative you could build the scenario 2 and scenario 4 and still be just about carbon negative. Next question for clients is it cheaper? Well, it turns out that all stone is marginally cheaper than the steel, a bit cheaper than the concrete, but the stone and timber is far cheaper still. And I think that's it. Yeah.
Great.
Great. Thanks a lot for this input. It was.
I rambled, didn't I? Just almost 50 minutes. Sorry.
No, it was really interesting. Thank you. So I think we already received a lot of questions in the chat, but again, to everybody listening, the chat is open. You can ask questions.
Yeah, but maybe we start with one question of our own. I think it's really interesting to see a lecture to discuss the topics of sustainability, bearing in mind that the building industry plays a dramatic part in the carbon footprint and global pollution. And we kind of wanted to address these questions also to our next generation of soon to become architects.
Yeah, so maybe the first question is about your sustainable or personal sustainable approach.
Yeah, yeah.
As we understand it, you have various levels where you approach sustainable ideas on various levels, like on the technical side with the green roof you mentioned, for example, or the materials you choose, but also on the conceptual side. Or the soft facts, so to say.
Yeah.
Like a long lifespan with flexible floor plans and so on. But do you have one strategy which is more important to you?
I think at the moment it's the difficulty you'll find. I mean, the best starting point is always to say choose materials. So let's say the best material to start off with is timber. Timber is going to be carbon negative as long as you don't over process it, i.e. you don't take spend a lot of energy and other materials to process it into some other type of glulam or beams and all the rest of it. Still better than concrete, but let's say you limit the amount of processing, timber is still going to remain carbon negative. So strictly speaking, you could decide all future construction is in timber. If we have sustainable forests, farmed forests that do that. And I think some of you might have come across Professor Crowther's study, ETH Zurich, who basically said, look, there's so much land that's in government and private ownership that's not farmed, that is lying idle, what sometimes we call brownfield sites. If we just forested those within 100 years, because obviously the trees are taking time to mature, we'd be at pre-industrial period atmospheric carbon levels. Yeah. If we then decided, okay, more seriously, let's take up other areas in addition to that, and they become sustainable farmed forests for the building industry. Effectively, what you're turning your building industry from a carbon positive, i.e. it's producing carbon, you're turning it into a carbon capture industry, aren't you? However, which is all great, it's theoretically great, and I think a lot of people don't realize that. They haven't quite grasped the concept that the building industry, because some people just simply say, why don't we just do nothing? If we just sit and do nothing, stop breathing, there's less carbon. Yeah. Obviously, the next stage is just do very little. We have very little growth. We have very little, whatever, all sorts of ideas without necessarily saying, well, actually, supposing we conceptually think of the building industry as a carbon capture industry. Now that, strictly speaking, you could say, as you saw in one of those diagrams, your building could be so carbon negative, you could actually replace some structures that if you strip them down and try to insulate them and make them function, they're still more positive. the amount of material you're using and the amount of heat they're losing or having to introduce is still more positive than the negative. So it makes sense to demolish some buildings and replace them with these carbon negative structures. So in a sense, your building industry can become perpetual in replacing older buildings where it makes sense, and you become a carbon negative industry at the same time. So you're almost promoting growth for carbon negative purposes. However, once we've got our head around that idea, let's propose timber for all structures. Well, in the UK, we've got new building regulations since the Grenfell fire saying no combustible material in the wall structures above ground +3. Yeah. So that's the limit you can go with the timber frame now. Yeah. So it basically means you can't have timber in the walls. You can have it in the floors. You can probably put glulam columns pulled back from the walls and then put a curtain wall in. Now, up to a certain point, that makes sense. But if you've got it in the external, if you need structure in the external area, then yes, stone is the next choice. So there you go from timber. Okay, I've got some timber, but I might need some stone.
Yeah.
So strictly speaking, you could say, and then people ask, surely stone is a finite material. We're going to run out of stone, and you have to remind them the Earth's crust is just the cooled down molten stone that we all sit on. So we're never going to run out of stone, and the quantity of the hole that you create to dig out stone for building purposes is a fraction of the holes, the multiple holes you have to dig out for cement or steel. Yeah, because ultimately steel is quarries of limestone, crushed, processed, burnt, and then it becomes think about 1/4 to 1/3 of the strength of the original limestone itself, requiring steel to be put in it to reinforce it. Now, you might ask today, well, who the hell would come up with such a stupid idea? Well, we're only asking today because it's a sustainable question. In the past, it was all to do with emblematic of the modern convenience, pouring as much concrete over floor plates as opposed to trying to make them out of stone or timber. But we ask those questions today, rightly so. So the next question is, if you have been able to design it all in timber or all in stone, and obviously you've got some glazing and no doubt some metal there somewhere as well. People forget, we're always going to have cement. We're always going to have metal. It's just about reducing the amount you use. If we've managed to get that far, the clients accepted it, the design team have accepted it. The next hurdle is, will your contractor accept it? And we're finding that's the last hurdle. So the main contractors turn around to you, and some of them are quite honest and say, why the hell would I turn around and give the client a building that's 25% less to build? I make money out of buying and putting more materials together. I don't want to make it cheaper. I don't want to make it out of these materials that you're saying are sustainable. It doesn't matter to me. So there aren't enough contractors who are willing to come on board with you. You have to really fight hard. And over time, hopefully your generation, new generation of architects, by that stage there'll be a new generation of contractors who realize that is the imperative at the moment, and they've got no choice. Hopefully it'll be, it'll be building regulations that do it.
Yeah, we had like a really interesting discussion according to this last week with people from the building industry, and this was also one question we prepared, like how do you convince clients as well as the contractors, because last week, like, it was for us at least some enlightenment that still the industry is quite I don't know, like
their own path. There is no way.
That's right. Yeah. Why? And you can understand why. You've been employed by a contractor. You're working for them. It's a risky industry. Why would you suddenly swap the method that you've known that's de-risked you? You're able to make a profit. Why would you swap that for something you've never done before?
Yeah, exactly.
It's a question of taking a risk maybe, but
Oh yeah.
I think in your project, it's really interesting to see that you do take the risk. Or in the residential project, you built the stair out of stone, then translate it into a whole building of Clerkenwell Close. And maybe to add another question to the material stone and sustainability, because you also curated an exhibition in the beginning of this year called Stone Age in the Building Centre in London. And there you refer to stone as having serious results.
Yeah.
And for us, it's really surprising to see that stone really is cheaper in the way we extract it nowadays with technical machines and everything. Is this really your point, that it is cheaper in comparison to concrete, for example? Or do you say that stone in the long term, it has a longer lifespan and therefore is more sustainable?
It depends on the stone you're buying. It depends on the quarry you're getting it from, the amount of effort that they have to put to extract the stone. Ultimately, you need to go to a stonemason to say, look, I would like it. I would like this stone to perform a certain structural purpose. So you're working with your structural engineer. Unless the client says, I need it to be a particular, whatever, green marble. If the client doesn't really mind on the stone, why not get the most inexpensive one you can get your hands on, as long as it's still performing structurally and for fire purposes, etc. So there's no reason, because ultimately what you have to do is not just look at the stone as if it's a facade. Is replacing your superstructure. So the quantity surveyor, and no doubt they're in your country the same as they are here, has what's called a cost plan book. And the cost plan book is broken into strict paragraphs, and they very rarely overlap. So the paragraphs are foundations, so substructure, another one superstructure, another one secondary structure, another one external finishes, cladding, another one internal finishes, and so on. Yeah. Now, if you take a piece of stone and say that stone is now the exoskeleton, the superstructure, but it's also the external finish. Yeah, exactly, the cladding. Very rarely are the quantity surveyors calculating that. Yeah. So you have to remind them that what you're doing is combining a series of materials to perform and taking one material to combine a series of functions that straddle that cost plan. So overall, it tends to be cheaper, and then depending on how far you're transporting it, certainly a lot more sustainable. For here at Clerkenwell, our sustainability engineer basically said, do you realize you've saved 92% of your carbon footprint by using a stone exoskeleton instead of steel? Yeah, exactly. And we said it was just crazy. We hadn't realized. We thought it was going to be, I thought it might save single figures or something. He said, I'll let you think about it and phone me when you realize why. And it took us a while, and we realized, oh yeah, of course, stone has got zero carbon. It's lying in a quarry. It was made for you already. A sedimentary stone would have been hundreds of million years old. If it's lava, basalt, so it came out of a volcano yesterday or a decade ago, but it's zero carbon. You're not processing it. The carbon that you're actually spending is the cutting tools, cutting it out, and then transporting it and erecting it on site. And he said, had you managed to persuade a British quarry to give you that stone, you would have been 90, I think it was 95, yeah. So it burnt an extra 3% of carbon in the transportation from northern France to the UK. So not a great deal in the overall balance, but worthwhile, isn't it? You can see.
But let's say if we, or do you want to?
No.
Let's say if we scale it to a wider context and we use it more in public, or it maybe
even replaces
concrete,
let's say.
Yeah, absolutely. Why not? That's the whole point. So that particular research tower, the idea was, well, can we, because the exhibition was on stone, they wanted to concentrate if everything was made out of stone, all the floors, the exoskeleton, the core, everything, yeah. And you could see from our, let's go back up. You could see the one on the far left is the one where everything is made out of stone. And it's less than half of the carbon footprint of the concrete version, and obviously a fraction of the steel frame version, which is, you know, is the standard way of building at the moment. Is mostly steel and often concrete. However, we know that there's an industry already prepared in doing floor slabs out of timber. So why not just say, why not use timber for the floors, and then the exoskeleton, the superstructure can be stone. And then once you do that, you also realize, well, it's obviously carbon negative by that stage. Yeah. So it's not even saving 90% or whatever it is of your embodied carbon. You're actually going into negative. Yeah. So why not replace housing? I mean, I'm going to stop sharing the presentation and try and find for you.
Maybe I can ask you. It's a mean question.
Go on.
But if we understand the title, the New Stone Age, and we say, okay, let's replace, for example, sand or concrete by stone. Don't you think that it's another way of using another material which is extracted linearly from the earth, and then in some years we will end up in the same problem, having the same problem like at the moment with sand, that we slowly start to run out because we use everything.
Yeah, but you know, there's a quarry outside Edinburgh. Do you know Edinburgh reasonably well? It's got the old medieval town, and then it's got the what they call the new town, the Georgian town. Yeah. So quite large city, 500,000. That quarry supplied the stone to build that city. That quarry is now obviously it's defunct. It's no longer active, and they've actually built a supermarket on top of it. Yeah, so they filled it in and built a supermarket on top of it. That's how small the quarry is, you know, to build a city of 500,000. So we're not going to run out of stone if that's what your worry is.
Yeah, kind of. At the moment, everything is a bit.
You're not going to run out of stone. Apart from that, most of, you know, it's not really. I mean, most developed countries, you know, we're not worrying about running out of materials, or it's places like China which have used more concrete than the whole of the States in its history in the last year. So it's those sort of countries which are rapidly developing, where you say, you know what, you've actually got plenty of stone, plenty of wood, you can farm sustainably. You could actually do exactly the same thing in those materials if you do it the following way.
Okay, so I think we have some questions from the audience here. So Brigitte Search says, thank you so much. I wonder what representation means for you. Carlo Lodoli, 18th century, from Venice, understood it as representation of the material itself, as something like a truth of material.
Yeah.
So how do you think about form and style regarding the working with different kinds of stone and with a material that may overlast for a very long period?
Yeah, so, well, answering that in reverse, you saw from Clerkenwell Close that it was one of the questions. So one of the fundamental questions of us working in stone is it cost effective? Will we be allowed to use it? Will the banks allow us to use it because they're financing the project ultimately? Is it expensive? Well, the answer was no. So that's first question answered. Second one, is it structurally able to do its job? simply as columns and beams without needing special reinforcements and stainless steel clamps and ties and post tensioning, which sort of defeat the purpose of our ambition? The answer is yes, it can do it on its own. The next question is then dressing, the architectural dressing. So stone in the past is obviously used during the classical, neoclassical, Gothic revival, Gothic periods. They all have their dressing that's emblematic of that period. Ultimately becomes emblematic of that period. So what do we choose? Are we going to carve it in anything special? That's where we found when we went to the quarry, as the stone is extracted, it's got its own finishes. Ultimately, some of them machined, some of them the natural sedimentary layer where you discover fossils. And we asked the quarry master, well, why is our stonemason suggesting that he wants to carve in a natural finish when this is the natural finish? And he said, well, the reality is no architects visit quarries, no stonemasons visit quarries. Normally, I just deliver clean-cut blocks to the stonemason, and he has his menu of finishes, and the architects choose from that menu, including a subsection called natural. And natural means taking a blowtorch to it with a chisel and trying to make it look like natural. We said, well, that's completely absurd. Why, what happens to all the lovely fossils in the stone? I said, well, I have to cut them off. Nobody wants them. They want clean blocks. I cut them off, crush them as aggregate for a road fill. Yeah. We asked, well, is it more expensive? Is it harder for you just to leave it? And he said, no, of course not. If you kept the beauty, in his opinion, of the stone itself, I'd be very happy. So that was our choice. The stone, as your questioner says, speaks for itself. It is if you like, the truth to the material. Does that answer that sort of answers?
Yeah. So,
mostly on stone, yeah.
It also shows that communication plays a big part in the role as an architect, that there is maybe a lack of communication in the interdisciplinaries as well. Precisely. It's that separation of disciplines now, where we are educated in schools, we go straight to the office. We're not told to go and visit a quarry. We're not told to go and ever work with our hands and find out how this stuff is put together. Yeah, so that's the Vasari lesson. Learn what these materials mean and how they're brought together. Yeah. Maybe before we come to an end, we have time for one last question from the audience. There is Carla asking, do you have a general method of choosing which material is most appropriate in each project? Well, the general method is not to make a choice until very late. So it's the idea we were saying earlier, which is, we try and delay that decision by allowing, well, basically doing the fundamental research into any site that any architect would do. So you do that. So you cut your sections and elevations of the existing context as wide as possible, because in doing so, what you're doing is walking up and down the street, looking at structures, looking at existing conditions, and learning from those what the context is. Does it matter? What is that context? Should you care, or should you perhaps not? While you're doing that, you're also then researching the context in terms of the social context. The stuff's not physically present. That might be talking to people who are present today, because they might give you insights into the social history or immediate social condition, but also into the past. And sometimes the past has an influence, sometimes it doesn't. But keep doing that, and eventually, while you're tackling the very fundamental issues of your design, because you've done all this research, there's a menu of ingredients out there orbiting your mind as a collective of architects, of us in the studio, that then allows us to pick and choose and compose them. And if one composition makes better sense than the other, then why not? We'll go for that direction. So it's not necessarily saying this is the ultimate and true
design, nothing can be better. It just turns out that our condition, that moment, that part of the year, that mood of when we'd rolled out of bed or whatever it was, didn't have enough coffee, our condition finally settled on that.
Great. Yes, great. Thank you.
You're welcome.
I think this was it, kind of. We're coming to an end. Thank you very much for these insights and the interesting discussion as well. It was very inspiring for us as students to have the opportunity to talk to you as an established architect, and yeah, kind of take these unusual ideas maybe and shape a more sustainable future.
Yeah, good luck. Look forward to your work.
Thanks.
Okay.
Yeah. So this was the last evening of the Jour Fixe series, and we just want to thank quickly to Professor Anne Bergner, Professor Marianne Müller, Claudia Nietzsche, as well as Bianca, Mina, Sebastian, and Xander, the next upcoming Jour Fixe team. We are already looking forward to next semester's events, and we will have new topics and a new curatorial concept. Yeah, thanks to everybody. Thank you, Amin.
Have a good evening. Bye-bye.
Bye, good evening.
Bye.